Systems of equations. Yesterday, we were subtracting equations from each other to eliminate one of the variables, and that's the whole key, is to eliminate one of the variables. Remember, x plus y equals 7 has an infinite amount of solutions. You got to get it down to just one variable, so we have to eliminate one of the variables. If the coefficients, which are the numbers in front of the variables, are exactly the same, then you could subtract the equations and they'll cancel out. 4 minus 4 is 0. If they're the same but different signs, then you can add the equations together. A 4 plus a negative 4, that cancels out to 0. If you think of numbers as money, positive being money you have and negative being money you owe, if you have $4 and you owe $4, that's a wash. It's basically like you have no money. They cancel each other out. Right, so if we add these two together, it's going to cancel those out because they're opposite signs. So let's add these two equations together. 4 plus a negative 4 is 0, so your x's are gone. This is two negative numbers that we're adding together. So again, think of these numbers as money. If it's a negative, that's debt. So you have $5 in debt plus another $3 in debt. Now you have $8 in debt, negative 8. When you add two negatives together, you get a bigger negative. Now here you have $12 and you're adding $28 in debt, a negative 28. You're adding more debt than what you can afford. That's going to put you into the negative by $16. Negative 16. If you're at 12 and you subtract 28, you go 16 below 0. All right, now you can solve for y by dividing by negative 8. Y is going to be equal to negative 16 divided by negative 8. A negative divided by a negative is a positive. So y equals positive 2 in this one. Once you have one variable solved, you plug it into either one of these equations and solve for the other one. I'm going to plug it into the first equation because everything just looks a little smaller and easier in that one. So I'm going to plug y equals 2 into this equation. So I'll have 4x minus 5 times 2 is equal to 12. What is 5 times 2? It's 10. So how do I solve for x? I add 10 to the other side and I divide by 4. 4x is equal to 22. That's 12 plus 10. And when you divide by 4, 22 divided by 4 reduces to 11 over 2. You can leave your answer like that if you want. You could say that's 5.5. You could also say it's 5.5. It just depends on what your choices are in the multiple choice. One of these three will be there, but there won't be both of them there. There's no one answer that's better than the other, so only one of these three choices will be there. You just have to recognize that they all mean the same thing. So there's your answer, 2 and 5.5. Let me show you another one where you can add. Here's another one where we have the same amount of x's, 3, but one's positive and one's negative. So we're not going to subtract these equations from each other. We're going to add. If we subtracted 3 minus a negative 3, minus a negative means to add. That would be a positive 6x, and that would not eliminate the x's. When you have one positive and one negative, you have to add them together. So we add these together. The x's are gone. This is 11y equals 33, so y equals 3. 33 divided by 11. I'll take that 3 and plug it into either one of the equations. How about the first one? 3x is equal plus 18 equals 20. How did I get 18? I substituted in the 3 for the y. 6 times 3 is 18. Now, two-step equation to solve for x, you subtract 18 to the other side to get 2, and then you divide by 3 to get 2/3. So x is 2/3 and y is 3 on that one. All right, that's not really a new lesson. That's just eliminating a variable by either adding or subtracting. Yesterday we subtracted, that was adding. The new lesson is substitution. Let's say you have 4x is equal to 3y as your one equation, and your other equation you have 5x minus 2y is equal to 7. All right, elimination might look Not so easy on this one. Your like terms don't line up. This equation is smaller. Let's make this one a little easier to start, actually. Let's just make that x. All right, so we're going to use substitution here. We've been trying to eliminate one variable to solve for the other one. We've always come up with y is equal to 2 or something, and then we substitute in the 2. Well, here, they pretty much tell us what x is equal to. It's equal to 3y. X is equal to 3y. I mean, it's not a whole number. It's a number and a term, but that's okay. As long as we know what x is equal to, we can substitute that into the next equation. It's like this problem's already halfway done, in a sense. They've already solved for x for us. It's equal to 3y, so we're just going to sub that right into the next equation. So wherever you see an x, you're going to switch that out for a 3y, because they're equal to each other. It's like saying 5 plus 2 is equal to 4 plus 3. They're equal to each other, so you could use either one of those, because they mean the same thing. That's what equal means. X is the same thing as 3y, so you can either use an x or you can use a 3y. We're going to use a 3y, that way we have all y's, and we just eliminated our x. So instead of 5 times x, it's 5 times 3y. Minus 2y equals 7. We haven't really done any math, we just substituted in something that was equal to something else. We took a player out of the game and put another player in. They play for the same team. They're equal. We took the x out. We put the 3y in. Now you can solve. 15y, that's 5 times 3, minus 2y equals 7. 15 minus 2 is 13y equals 7. Divide by 13. Y is equal to 7 divided by 13. A fraction, 7/13. We're done. That's y. That's what y equals. All right, and then we could substitute that back in to solve for x, but I'm not going to mess with that because it's an ugly fraction. Well, I'll do it anyway. Substitute in. Y is equal to 7 over 13, so we plug that into here. So x is equal to 3 times 7 over 13, which is 21 over 13. So those are your answers, 21/13 and 7/13 for a problem like that. Substitution. It can work out real well if you already have one of your variables isolated like that. Let me give you one that's a little bit more complicated. Let's say they've already got y by itself and it actually looks like y equals mx plus b. And then the next one will be, say, 2x plus 3y equals 6. All right, same thing. We already know what y is equal to. It's equal to a lot. It's not equal to one single number, but at least we know y is equal to this. We can substitute in 2x plus 5 wherever we see a y in the other equation. And we see a y right here. So if we get rid of that y and make it a 2x plus 5, now all we have are x's here. We only have one variable, and that's what we want. We've eliminated our y. So let's do that. 2x stays 2x. This is 3 times whatever this y is, and this y is all of that. So this is 3 times 2x plus 5 is equal to 6. These two things are the exact same. 3 times y or 3 times 2x plus 5 means the same thing because y and 2x plus 5 are equal to each other. All right, so you can use either one. We're using the 2x plus 5, so now we only have x's. Now we can solve for x. When you solve for x, you get rid of your parenthesis first by distributing. So 3 times 2 is 6x, 3 times 5 is 15. Now you combine your like terms, that's 8x. Now it's a two-step equation. Subtract 15, divide by 8. X is equal to negative 9. 8x is equal to negative 9. 6 minus 15 is negative 9. Now you divide by 8 and you get negative 9 eighths. Negative 9 eighths for x. And then you would substitute that negative 9 eighths in for this x here to solve for y, but the problems aren't going to be that difficult, so I'm not going to do that. But that's substitution. So substitution is easier when you have a problem that already has the x or the y all by itself. Then you just substitute whatever it's equal to in for that letter. If they give you a y, you substitute it in for y. On the first example, if I told you what x is equal to, then you substitute it in for x. You solve it and you're off to the races. So that's your second method for solving systems of equations. It's called substitution.